Welcome to the review for logs and exponential functions. This is part of topic 1 for IB Math SL. First, let's talk about what log and exponential functions are. An exponential function is a function of the form y equals constant base raised to the power of x. It is not to be mixed up with a power function, which is a variable x raised to a constant power b. So don't get those two mixed up. They look very similar. A log function is an inverse of an exponential function. Inverses are functions whose operations are opposite, so they will undo each other's effect. They also have domains and ranges that are the opposite. This is really going to help us when we go to graph them. On the paper, you'll see that I have one of our tests for finding out if two functions are inverses. Because their operations should be opposite, they should, in effect, undo each other's operations. So when you compose two functions that are inverses, either way, you'll get an end result of the input you put into the functions. They are undoing the effect of the other function. Below this, we're going to start by graphing our exponential functions. I have two different graphs because an exponential function will look different depending on the type of base that you have. All the bases must be greater than 0, but that still leaves us with two different categories. Our base could be a fraction less than 1, or it could be a number bigger than 1. If your base is equal to 1, you actually end up with a line, y equals 1. If you think about it, 1 raised to any power will always be 1. So technically it wouldn't be much of an exponential function. Both types of exponentials, no matter what the base is, have some features in common. Both functions will have a y-intercept at 1. Both functions will have an asymptote at the x-axis, or y equals 0. The main difference between the two functions is whether they increase or decrease as we move from left to right. When the base is bigger than 1, your output is going to increase as the x increases. And when the base is smaller than 1, the output will decrease as the x increases. Now, one trick for finding out your base if you're looking at a graph, you first have to check that it doesn't have any other transformations on it, so I always check for that y-intercept and the asymptote. If there are no transformations, to find out your base, you can look at the coordinates of 1, comma, b. So this might also help you to tell which kind of base you have. If your b is less than the 1, then you'll have a decreasing function. Let's use the definition for inverses to draw our graphs for the logs. All of the x values on the log function will be the y values from the exponential function, and vice versa. So instead of an y-intercept of 1, we will have an x-intercept of 1. And instead of a horizontal asymptote, we will have a vertical asymptote. All of the other points are also switched. X and y switch places. In effect, this means that the graphs will look like they were reflected across the line y equals x. So I'll use this to help me sketch the graph. Instead of the coordinates 1, comma, b, I'm going to have b, comma, 1, where b is greater than 1. And then I can use the same technique on the other graph. In this case, we will have b, comma, 1, with b being less than 1. All right, for our last topic for logs and exponentials, you'll be asked to solve equations using logs and exponentials. So the first thing that you'll need to know is how to switch forms between a log form and an exponential form. So on this next page, we'll talk about that. If you have an exponential function, again, the form y equals b to the power of x, and you want to change it to a log, the domain and range will switch places, so the x will now be what the log is equal to as its output, and the y will now be inside the log with the same base as the exponential. Oops, equal sign. Below that, I've got a bunch of exponent and log properties that you should know from previous classes. The only ones, unfortunately, that will be on the Math SL formula book are the first 4 log properties here. Everything else you have to be familiar with. I would strongly recommend taking some time to practice with each of these properties if you haven't done that in a while. Please keep in mind that as you're solving exponential and log equations, that if your variable that you're solving for is stuck in the exponent position or inside of the log, you will have to change forms in order to solve for it. You can also use any of these properties at any time to combine terms or rewrite an expression in order to better solve for your variable. I'm going to give you a moment now to look at all of these properties and make sure you write down any that you want to spend extra time with. Again, thank you for watching and stay tuned for the third and final video in topic 1. Bye!